All right, class, let's continue with this section 4.4. So we left off once I explained to you about the d-test and how that works. And so now let's just use it to find these relative extreme values. In other words, what? Min or max, possibly, or maybe neither. Yes. For this function. Now, if you do remember from the first part of the video, we in fact already found the critical point, right? It's the same function, as a matter of fact, that we had already gone over in the first part of the video. So we found that critical point to be the point of coordinates 2, 3. So we don't have to go through that part of the work again. So let's just continue here. So to find a min or a max, again, step 1 was to do what? Find the critical points. Yes, we did. So the critical point, remember, was the critical number equivalent from chapter 2. Okay, so now we're actually putting in a point inside the function, so an x and a y. So that was 2, 3. Okay, all right. Then the second part of this problem is to decide if this 2, 3 is a min or a max using the d-test. And the d-test, if you remember again from the first part of the section, is the equivalent of the second derivative test from chapter 2 that we took. Okay, so what we need to find that d function. Well, to find that d function is the second derivative, so remember. So we have 4 second derivatives, we're going to have to find them all. Okay, so if I were to have the paper in front of me, we could copy again the first derivative, but it's really not that bad. I could just quickly bust it up again. So that's a 10x plus 4y minus 32. And fy was negative 6y plus 4x plus 10. Okay, so again, we use finding the first derivative because sure enough, we want to find the second derivative using that. So what's the second derivative? fxx is just a 10, yes. fxy is just a 4. Now, of course, fyx would also be a 4, but we don't really need it in the d-test for that reason because they're the same, so we can use one of them twice. And then fyy is negative 6. So out of these 4 functions, we can create this d function, which was what? fxx times fyy minus the product of the mixed up. So again, because they were the same, you just get to find one of them and square it, right? Okay, so fxx is 10, fyy is negative 6, and fxy is 4. And you square that. So you get a negative 60 minus 16, which is a negative 76. So the point of it is that this value is negative, so less than 0, right? So according to the d-test, if this d value comes up to be negative, then in fact your critical point is a saddle point, and it's neither a min nor a max. So the one thing was that we did not get to plug in this point 2, 3 into the function. Why didn't we get to plug it in? Well, because as it so happens, these second derivative all turn out to be constants. There was no more x and y left in either one of them. So that d function, once we create it, is just a constant, right? So in other words, it's kind of like using a second derivative test for the functions in one variable and finding out that that second derivative is always negative. So always negative means that the function's only concave down on the whole place, right? So there was nothing to plug in. However, this was still the only point where there was a zero derivative, right? Where the min or the max could have happened, right? Could have occurred. So it turns out that it's neither a min nor a max, right? That it's a saddle point. So yet the second derivative is always negative, right? This d function. Okay. All right, let's see if we have better luck. And again, why did they turn out to be constant? Because these exponents were just 2. So once you got down to the second derivative, they're gone, right? So there's no x's left. So as you see, there's an x cubed there. So hopefully we'll still have an x by the time we get to that second derivative. So again, find the relative extreme values of this function. Great. What do? We find those critical points. Now, how do I find the critical points? Well, find the 2 first derivatives and set them equal to 0. So, the derivative with respect to x is a 3x squared minus 3. Okay. The derivative with respect to y is negative 2y plus 6. Great. That's not too bad. I'm setting them equal to 0. So even though I have 2 equations in 2 variables, either one of these equations only has 1 variable in them, right? So that's the nice thing about it. So we don't need to really solve a system. So I'm solving each of these equations separately. They only have 1 variable in them. 3 can never equal to 0, but x squared minus 1 can be 0. Right, that makes x squared equal to 1. So sure enough, x is plus or minus 1, right? It's a quadratic equation. It's going to have 2 answers. Don't forget about the plus or minus. And 3 is just 3. 3 is not 0 in this product, right? What could be 0 in a product? Variable factors, right? Because they can vary. Okay. Solving this equation, that's a linear equation. The exponent of y is a 1, so that easily means that y is going to equal to 3, right? So only one choice for y. So we found 2 critical points. I'll write them right here. The 2 critical points I found were 1, 3 and negative 1, 3. I have 2 options, right? Only one option for y, but 2 different options for x, yes? And that makes up 2 different points. Good. The second step of this problem is to use the d-test to decide if either one of these might be mins or maximums. Good. So for that d-test to happen, I need the second derivatives. So I have them right here. fxx, in fact, is 6x. fxy, there is no y in fx, so that's a 0. And fyy, of y with respect to y, that's just a negative 2. Good. So that d function is, one more time, fxx times fxyy minus fxy squared. So it's a 6x times negative 2 minus 0 squared, right? Okay. So multiplying this, that's a negative 12x. So sure enough, as it should happen, right, for more complicated functions, you definitely should still have some variables left by the time you get to that second derivative. So that's a good thing. Now I'm going to test these points and decide if they're mins or a maximum. So test the critical points. Okay, that's what the d-test is. So plug one of them at a time into the d function. Well, this d is a negative 12x. When I plug in 1, 3, negative 12 times 1 for x, that's it. That's all there is to plug in, just an x. That's a negative 12, right? Which is a negative value. So that simply means that what? This point that we found, 1, 3, is a saddle point, not a min nor a max. Okay, so 1, 3 is a saddle point because, again, just like the problem before, right, we found the d value to be a negative. So according to the d-test, that means you got yourself a saddle point. Okay, we have, though, a second point to test. This time x is a negative 1, yes, to plug in here. Now that makes it a positive 12, and that's a positive value, right? So what does that mean that the D value came up to be positive? Okay, if you look back in those notes, a positive D doesn't mean, yes, a smiley face. A positive D simply means success. You have a min or a max. Now, who decides on the tiebreaker? Who decides if it's going to be a min or a max? Remember what I explained to you in the previous video? It's either both of these are positive or both of those are negative. So all you have to do is test it just in fxx. Okay. So look at fxx. Plug in this -1, 3 and see the sign of that. That's your tiebreaker between being a min or a max. So fxx is a 6x. So when I plug in the x of -1, yes, in here into this function, I'll get a -6, and that's a negative, right? So a negative means just as it meant in chapter 2, there you got yourself a sad face. So a sad face means again a maximum, yes? So one more time means -1, 3 is a max. Okay, so that leads to a maximum value. What is that maximum value? So let me write that down. The maximum value is that this function's going to take is f of -1, 3. So I'm supposed to put in this input. So we know this input will lead us to a highest point on the graph. So what's the highest point on the graph? So I'm plugging it into the function to get that y value, right? From before, it's a z value now when you have more than one variable. So it says -1 cubed minus 3 squared minus 3 times -1 plus 6 times 3. So that's -1 minus 9 is -10 plus 21, that's going to be an 11. So that maximum value is an 11. All right? Okay. So let's continue with one wordy problem. And it's the same kind of wordy problem that we had back in chapter 2 about price and quantity, and the price depends on the quantity of items you are purchasing, and of course revenue and cost. So let's read the problem. The only difference is now you're not producing just one item, you're producing 2 items, yes? So a company produces chairs and tables. The price function for each chair is right here, yes? So one more time, that means what? What does it mean that this is the price function? It simply means that if you buy what? 1 chair, yes, the price function or the price at which we're going to charge you is $119, yes? If you're going to buy 2 chairs, we're going to charge you how much? $118 a piece, yes? So still, times 2, that makes more money, right? If you're going to sell you 3 chairs, you're going to be charging $117 a piece, right? So x is the amount of chairs, yes? Okay. And the price function for each table, oh, well, look at me. One time I forget each, one time I forget 4. Is right here. So that again means what? If you're going to buy 1 table, how much do we charge you? 180 minus 2 is 178, yes? If you're going to buy 2 tables, how much do we charge per table? Is 176. And so on. If you're going to buy 3 tables, we're only going to charge 174 per table, yes? So again, where y is the amount of tables, both in dollars, fine. The cost function for producing these chairs and tables is right here. So the good news is we don't need to set it up. Okay. Find the quantities and the prices of the two products that maximize the profit, and then also find the maximum profit. Good. So one more time, how do we make profit? Well, by selling things, whoops, and figuring in, factoring in the cost, right? So you sell some chairs and some tables. We have the prices and the quantities there. And then there's a cost involved in producing these chairs and these tables. And the difference between that is what money is left in your pocket, or in this company's pocket, for that matter. Good. How do you make revenue? Well, you sell some amount of items at a certain price. So that's your number of items, and that's the price per item. You're going to sell what? A second type of item, which is the tables, at a price per item. Okay. Minus the cost function. Don't forget again to put that in a parentheses. Okay. So I'm going to put all that together. Hopefully the correct way. That's going to be a negative x squared. It's going to be 120x minus the 60x from here. That's 60x. Minus 2y squared from here. And that's 180y minus 80y, which is 100y. And then minus 2xy. And then minus the 200. Okay. All right. So I just combined these like terms. The 120x and then the minus 60x, and then the 180y, and then of course the minus 80y. Okay, so here's your function. To minimize it or maximize it, what's the first step? So we want to maximize this function. Step one is to find those critical numbers, possible critical points. Yes? Okay, so how do I find the critical points? Find the derivatives, set them equal to 0. Okay, so the derivative with respect to x is negative 2x plus 60 minus 2y. The derivative with respect to y is negative 4y plus 100 minus 2x. So again, what do? I should have done this first. Set each of them equal to 0. Okay, so what you got yourself again is a system of two equations and two variables, right? Then there's one of each in each equation, so that's a system, right? So I'm going to rearrange these, and we're going to solve this system. Okay, so what do I mean by rearrange them? Keep the x and the y terms on one side, throw the constant over, and then keep the x and the y terms on one side, and throw the constant over. So in fact, again, this is a pretty easy system to solve. As you see, the x's are almost the same. All we need to do is make them opposite coefficients, right? So that when I add these two equations, the x's will disappear. So one easy thing is to multiply the top equation by a negative 1, right? So I'm not going to recopy it, but what that does is changes all the signs, yes? So when I add these two equations, I will be left with no x's. 2y minus 4y is negative 2y. And 60 minus 100 is negative 40, right? So that easily makes y equal to 20. Yes. Now, take this back here and plug it into either one of the equations and get the x out. So I'll use the first one that says negative 2x minus 2y, which I now know is 20, is negative 60. That's negative 40. Throw that over as a negative 20. So x is a positive 10. So that came up nicely. Okay, so these are the values. Now, just to be sure, I'm going to see, this is my critical point, yes? So let me write it down. So this is the critical point I found. Okay. Now, whenever we solve the word problems in chapter 2, I said, don't bother really. Whatever we're asking you for should be the thing that comes up. In other words, what? Should indeed be the minimum or the maximum for that function. But let's just double check and make sure I set it up right. These numbers are not easy to make up. It just has to be just so. So let's, to practice, use the d-test. I'm keeping my fingers crossed that this is going to work. Okay, so for that, I need a pxx, which is -2. Pxy, which is -2. And a pyy, which is -4, right? So the d-test is, the d-test. So you're going to take these functions and multiply them, right? Pxx times pyy minus pxy squared. So that's a -2 times a -4 minus -2 squared. So that's an 8. Minus -2 squared is a positive. I'm sorry. Yeah, that's a +4, but 8 minus 4 is a +4, so that's a positive value, right? So again, a positive d-test value means that what? That we have a min or a max. How do I decide which one it is? I have to look at pxx. Remember, my function's called p and not f. Okay. Pxx is a -2. So same as in chapter 2, a negative value is a sad face. So a sad face means that we have a maximum. So in other words, what? This critical point that we found gives us a max. Just as we asked for, right? Just as promised. Okay. So that was just the testing. As I said, we could have easily skipped this part. Now let's make sure that we answer the questions of the problem. Okay, so X was the what? X was the amount of chairs. We found it. Y is the amount of tables. We found it. So let's see what we need to answer, right? So always go back, read, make sure you answer all the questions. It says, find the quantities. Well, what are the quantities? The amount of chairs and the amount of tables. So we found what? We have what? 10 chairs. And 20 tables. Yes. What's the next part? And the prices of the two products. Yes. That will maximize the profit. What are the prices? Well, the price for the chairs is 120 minus X. So I'm going to go back here. So 10 chairs at what? 120 minus X would be 120 minus 10, which is $110 each. And the tables were sold at 180 minus 2Y. So that would be $140 each. Yes. All right. 220, yeah, $140 each. Yes. So we found the quantities and their prices. Yes. And it says also, sorry about going back, but you have the whole page in front of you. So also find the maximum profit. So now let's plug in these values into the profit function and see what we get. So the profit function said negative x squared plus 60x minus 2y squared plus 100y minus 2 times x times y and minus 200. So plug this in. I should have done this. I know I did somewhere. Oh, where's my calculator? I don't know. Oh, fine. I'll just do it in my head. So that's negative 100 plus 600, that's 500. 500, 400, 500 minus 800 is negative 300. Plus 200, I'm at negative 100. Wait a minute. Am I getting a negative? I know I did this, and it was coming up right. 180. No, what's 100? Oh, that's a 2,000. I lost my track. It's a number. Go ahead and figure it out. Negative 100 plus 600 is 500. That's 400 minus 800, negative 300. And that's a 2,000. So that's 1,700, 1,500, 1,300, if I'm correct. Hopefully you got to that answer faster. So that's your maximum profit, okay? Maximum profit. All right, well, there you go. There it is, okay? And that's kind of how I would have wished you guys would answer all those questions on the test as well, right? Don't just give me some X you never defined, some Y you never defined, no units whatsoever. You are forcing me to take points off, right? Look at those units. There's a dollar sign, yes? There's chairs and tables, right? This much each, and I know it's about the chairs. So there's a story, right, I can use. All right. So 4.5 will be next.